Hello everyone, very good morning all. Welcome to SSR Concepts Learn Easy with us. Today I am here with one more interesting topic in light. So let me start the screen share of the PPT so you can understand better. Okay. Light is a topic which you have correlated in both 10th and 12th class. It is one of the most important topic. Okay. So for a light, where does light comes? It requires various sources, right? We require various sources of light. So what are the different sources of light? In the previous class, just we have introduced what are the different sources of light. So what are the different sources of light? In our daily life, we see sunlight, right? Without sunlight, can we survive? No. So sunlight is one of the most important light source. So along with sunlight, fire, here in this slide, you can observe the various sources of light. Sun, fire, stars, flashlight, light bulb, candle, flame. These are the various sources of light what we see in our daily life. Okay. So based upon the sources of light, how can the objects can be classified? Based upon the sources of light, how these objects can be classified? In the previous class, we have introduced what are luminous objects and what are non-luminous objects. So based upon the sources of light, objects can be categorized into two ways. One is luminous objects and the non-luminous objects. Right? What are luminous objects and what are non-luminous objects? These in turn can be called visible and the invisible objects. Right? So what are these luminous objects? By the way, you got to know what are luminous objects and what are non-luminous objects. Luminous objects are the objects which have their own capacity to emit light. They have their own capacity to emit light, right? And the non-luminous objects are the objects which does not have their capacity to emit their own light. Non-luminous objects, non means nothing. It does not have a capacity to emit its own light. Simply you keep remember, luminous light. Non-luminous does not have the capacity to emit its light. What are the examples of luminous and non-luminous objects, children? One of the best example for luminous object is nothing but sunlight, right? And one of the best example for a non-luminous object is moon. Does moon has a capacity to emit its own light? No. Moon does not have the capacity to emit its own light. There is one basic phenomenon. How does the moon emit light? That is nothing but the reflection. Further deep, we are going to discuss in today's class what is reflection. Okay. By now, you came to know what are the different sources of light. Now, this light, how does it move? For light to move, what does it require? It requires a medium, right? Light requires some medium to travel. What is a medium? Medium is nothing but a substance through which, here in this line you can see the definition. A medium is nothing but a substance through which light propagates. A substance through which light propagates. Okay, propagates means nothing but travel. A substance through which light travels or propagates is nothing but a medium. Light requires medium to travel, right? So based upon this medium, objects are again classified into three types. Objects are again classified into three types. What are the three types of objects based upon the medium can be classified? Transparent objects, translucent objects, and opaque objects. Here you can see in this slide, translucent, transparent, and opaque objects. What are those? What are those, children? Transparent objects. Transparent objects has the capacity to pass the complete light through it. Okay, if suppose this is the object, you think my hand is an object here. Transparent objects has the capacity to completely passes light backwards. Okay, here the light enters and backside the light also complete capacity it has to pass through the object. So what are translucent objects? Translucent objects means only some amount of light can pass through an object. Transparent can completely pass the light, and lucent means only some amount of light can pass through it. Only some amount of light can pass through it. These are nothing but the translucent objects. Coming to the opaque objects. Opaque objects can't pass the light. It does not have the capacity to pass the light backside. First, suppose if you think this is the object, this is the book is an object here. The light ray is coming here. It does not have the capacity to pass the light. It does not have the capacity to pass the light backwards. Right? These are nothing but the opaque objects. These are nothing but the opaque objects. Based upon the medium, objects can be classified into transparent, translucent, and opaque objects. Transparent objects are the objects which has a capacity to complete passes of light. Translucent does not only, it allows only some amount of light to pass. Opaque objects does not have the capacity to pass the light. Here in this slide, you can note down the various examples. Transparent examples are glass, water, and air. Translucent examples are frosted glass, wax paper, and the butter paper. Opaque objects, one of the best example, wood allows light to pass. No. So wood is an example of opaque objects. Metal is an example. Rubber is an example for opaque objects. Right, children? Right? So, by the way, you got to know what are the sources of light? What is the medium of light? Okay, how does the light travels and what from where we get light? So, based upon the sources, two types of objects can be classified. One is luminous objects and another one is non-luminous objects. Based upon the medium, objects can be classified into three types: transparent, translucent, and opaque objects. So, we all discussed. Light travels in a straight path. This is one of the important property. In the previous class, we came to know what are the properties of light. In that, one of the important property, light always travels in a straight line. How it travels? How the light travels? In general, we consider light travels in the form of a ray. Light travels in the form of a ray. You can see here the ray. This is the representation of the ray. How the ray is represented? The representation of ray is a straight line and keep an arrow mark. This is a ray. Right? Light always travels in the form of a ray. So here the light rays. How can these light rays classified? Okay, how can these light rays classified? Only one single ray passes in the medium. Only one single ray passes in the medium? No. A beam of light rays travels. Okay, a beam of light rays travels. So based upon this, we can classify it into three types: convergent rays, divergent rays, and parallel rays. Here in this slide, you can see what are convergent rays, what are divergent rays, and what are parallel rays. Children, don't get confused. I will explain in detail what are convergent, what are divergent, and what are parallel. Okay, just simply you observe the topic. Okay, what are convergent rays, what are divergent rays, what are parallel rays? Don't get confused. A simple way here to remember, it's a simple technique. Converging means coming together. All the rays are converging means coming together nearby you. Okay, here in this C diagram, you can observe what are these are the different rays. Okay, this is one light ray, this is one light ray, this is one light ray. All the light rays are meeting at a point. This is the point where all the light rays are meeting. Here you can see the arrow I kept here. This is the point where all these light rays are meeting at a particular point. means converging, coming together. Converging means coming together. That is nothing but a convergent beam or a convergent ray. Coming to the divergent ray or a diverging ray or a divergent beam, you can call anyway. Here what happens? Here what happens? All the light rays are going away from the point. Here, this is the point. If you think this is the point, from the particular point, all the light rays are going back. You can see in this figure. Children, observe this figure. Here, converging, all the light rays are coming together. Diverging means all the light rays are going back from a particular point. Diverging, diverging means dispersion, going out. You just remember, diverging means dispersion. A light ray disperse, go back. It diverges from a point. Okay, this is the divergent beam. So what is a parallel beam? We just discussed all light rays goes in a straight path. All the light rays goes in a straight path, right? In a parallel to each other. Or if the light rays are going in a straight path and are going in which are parallel to each other. All these light rays goes parallel to each other. That is nothing but a parallel beam. Children, got now convergent means together from a point. Okay, all the light rays join at a point. Divergent means disperse from the point. And parallel means light rays which moves parallel to each other in a straight line. Okay, children. By now, you came to know what are the sources required for a light, what are the sources of light, what is the medium, based upon the medium, what is the classification of object, and what are the light rays, and how you can classify these rays. Based upon this classification, 3 types of rays, convergent ray, divergent ray, and the parallel rays you have just now discussed. And coming to the actual topic and one of the important topic for your IP and for both. Okay, neat. Now, children, just you understand the concept. Don't by heart the concept. This is the reflection of light. Okay, if you understand the concept, you can write. Okay, just you don't get confused. I will tell in a simple way, reflection of light. What is meant by reflection? Children, I will ask you one question. How can we see different objects around us? How can we see the objects around us? As we said, there are luminous objects which can emit their own light. It has capacity to emit the light. So we can directly see the objects of which can emit light. But non-luminous objects do not emit light. But how still we are able to see? As we just said, wood does not have the capacity to pass light. It is an opaque object. Just now we discussed opaque objects. Light does not pass through it. How? But still, how we are able to see those things? Here, there is one phenomenon involved. That is nothing but the reflection. To see the non-luminous objects or illuminating objects, one phenomenon is required. That is nothing but the reflection. That is nothing but the reflection of light. Here, what's happening actually in the reflection? Okay, first you have to know what is the definition of reflection, right? What is the definition of reflection? Okay, what is reflection? It is a phenomenon of bouncing back. It is a phenomenon of bouncing back. Just I'm going, bouncing back. I'm going back. I'm coming. Right? Coming near to you. I'm going back. Right? Like that, reflection is the phenomenon of bouncing back of light. Okay? Where in the same medium, this is one of the important points, where the reflection bounces back. Reflection is the phenomenon of bouncing back in the same medium. Where when it bounces back, when the light ray bounces back, it bounces back when it strikes any object or any surface. Right, children? Right, children? It's when the light ray strikes an object. This is an object. But this is the light ray. When the light ray strikes an object, it bounces back. Right. Let me give you one example. Okay, let me give you one example. What is that example? Children, we all play with a ball, right? We all play with a ball. For example, if you think this is a ball. This is a ball. Okay. I'm throwing the ball with the force. I'm throwing the ball with the force towards the ball. Right? Just I have thrown a ball with a force. With this amount of force. Does the ball sticks to the ball? What happens there? The ball bounces back. Okay, the ball bounces back, right? We are throwing a ball towards the ball. The ball bounces back. In turn, bounces back towards you, right? Yes? So, with how much force you have thrown the ball, with that much force, the ball also bounces back. Like this. Like this. Here, the same concept, if you apply, one light ray is coming and striking the ball, and with the same force, it is bouncing back. And with the same force, it is bouncing. When the light ray is coming and hitting the surface within the same media, it bounces back with the same force. Okay, here, let me show the diagram here. This is green color line. First, suppose this is, you imagine as an object, any object. First, suppose I'm imagining this one as a mirror. I'm imagining this one as a mirror. This is the light ray. This is the light ray. Here, see the arrow mark where I kept? That is the light ray. Okay, this light ray is coming and striking the object. This light ray is coming here and striking the object. Means striking the mirror. The light ray which is coming and striking the object is called as incident ray. Children, observe the light ray which is coming and striking the object. The light ray which is coming and striking the object is called as incident ray. Okay. Don't get confused. Coming towards the object is called as incident ray. What happens here? What happens here? Again, it is striking the object. Again, it should reflect back. This light ray which hits the ball, again this light ray should reflect back. Here you can see, this is the light ray which is striken to the object and again it is reflected back. The light ray which is reflected back is called as reflected ray. The light ray which is reflected backwards again after striking an object is called as reflected ray. So, if we want to know what is the incident ray, what is the reflected ray, okay, we have to imagine, we have to draw an imaginary line, okay, which is perpendicular to this surface. Here I have taken this surface, this object, or I am imagining this is a mirror. Okay, we have to draw one perpendicular line to the object. This is a perpendicular line we have drawn. This is nothing but the imaginary. You have to imagine that line. I'm imagining this is the normal. One, I have taken this is an object. I have drawn this is the normal. One light ray came and hit the object. This is nothing but we have learned this is the incident ray. And this light ray again after striking the object, it is reflected back. It is reflected back. This is the reflected ray. Simply this is nothing but the reflection. What is reflection? What we said, one light ray is coming and striking an object and again it bouncing back. This is the nothing but what I said, reflection. Here the light ray is coming. Here two terms you got, incident ray and the reflected ray and the normal. Two terms you got, incident ray. You just remember what is incident ray. Light ray coming and striking an object is called incident ray. Light ray which is reflected back after striking an object is called reflected ray. After striking an object is called reflected ray. Now, here, one more important thing. The instant ray after striking, if we want to know with how much angle the light came and to know the angle of incidence and angle of reflection. What is the angle of incidence and what is the angle of reflection? Here, simply you remember angle of incidence. Here, the light ray is coming and striking the object and making one angle with this normal. You can see one triangle formation. If I draw it like this, here you can see a triangle formation like this, right? Here, this incident ray is making some angle with the normal. What we have drawn an imaginary line, that is nothing but the normal, right? Here, this incident ray is making some angle. That incident ray, the angle which is made by the incident ray with the normal is called as angle of incidence. The angle of incidence is nothing but incident ray to the normal. The angle which has been calculated from the incident ray to the normal is called as angle of incidence. And angle of reflection is nothing but the angle made from the reflected ray with the normal. Just you can see incidence, incident ray, reflection, reflected ray. Just you remember the words. Angle of reflection means normal to the reflected ray. Angle of incidence means normal to the incident. The angles made by. Understood, children? Clearly the concept of reflection. In the reflection, you have to get incident ray. What is incident ray? What is reflected ray? What is the angle of incidence and what is the angle of reflection? Now, there are some laws of reflection. There are some laws of reflection. You have to know there are two important laws in reflection. What are the two important laws in reflection? We have already discussed angle of incidence and the angle of reflection. Right. The first law of reflection is the angle of incidence is always equal to the angle of reflection. Angle of incidence is always equal to the angle of reflection. Why? Just now I have given you example how much force the ball you have thrown to the wall, with that much force it will bounces back like that. All a light ray with how much force, with how much capacity a light ray can travel in the medium, with that much capacity it will reflect back. So angle of incidence is always equal to angle of reflection. Keep in mind, the first law of reflection is angle of incidence is always equal to angle of reflection. And what is the second law of reflection, children? Here you see the diagram. Here what is happening? The incident, this is the incident ray and this is the reflected ray and this is the normal ray. Where all these rays lies in the same plane. This is the object what you have taken. This is the same plane, one plane. The angle of incidence, the angle of reflection is going. Here the incident ray, the normal and the reflected ray lies in the same plane. The second law is, remember, the incident ray, the reflected ray and the normal ray lies in the same plane. Lies in the same plane. These are the two important laws. You have to know. Okay. And by the way, you came to know the sources of light, the medium required for light and their classification. So what are light rays? Based upon the light rays, convergent, divergent and the parallel beams you have known. And next, what you have learned, one of the important concept, that is reflection you got, right? Reflection and the laws of reflection. Along with this chapter, we are going deep into the chapter. Careful children, just listen the concept, understand the concept. Don't by heart it, okay? Just understand the concept in easy way. Now, one of the important topic, we are going deep into the subject, that is mirrors. Okay, mirrors. What are mirrors, children? We all know mirrors, right? What they are made up of? What the mirrors are made up of? All the mirrors are made up of glass, right? All the mirrors are made up of nothing but glass. Here, all the mirrors are made up of glass. With, this is a mirror, if you think my hand is a mirror, if you think this is the mirror, one side is glass and the other side I have polished this side. This side, see, this is the mirror front side, this is the mirror back side. The back side of the mirror I have polished. Okay, always the back side of the mirror is polished. Okay, with what? Mostly mirrors are polished with silver. Why do they opt silver? Children, keep in mind, this is one of the important topic for your need. Why do mirrors are opted to polish with silver? Because silver has the capacity, 98% it has a capacity to reflect back the light. Silver has the capacity, 98% of the silver can reflect back the light. So, mirrors are of two types of mirrors you can see. What are the two types of mirrors? One is plain mirror and another one is spherical mirrors. One is plain mirrors and spherical mirror. Spherical mirrors are also called as curved mirrors. Spherical mirrors are also called as curved mirrors. So plane mirrors, how can we classify the spherical mirrors, plane mirrors? By what base you have been classified? This is a plane mirror, this is a spherical mirror, these are curved lines, these are the curved mirrors. How can we see? Based upon the reflecting surface, we can classify these mirrors. So what is the reflecting surface? According to the reflecting surface, this is the reflecting surface. Okay, this is a reflecting surface. So based upon this reflecting surface, it has. For a plane mirror, keep in mind, children, these are one of important bits for your NEET exam. Keep in mind, for plane mirrors, always the reflected surfaces, the reflecting surface is flat. For a plane mirror, always the reflecting surface is flat. And for spherical mirrors, you can see there are again two types of spherical mirrors. One is convex and concave mirrors. One is convex and concave mirrors. You can see here in the PPT, in this image, these are the concave mirrors and these are the convex mirror. For suppose this is, I am drawing a ball here. This is, you just draw a round ball here. I am taking a ball here. Just cut that ball. You can observe this one. If you think this is a ball, I have cutted the ball. You can observe this thing, this shape, right? You can observe. Now what happened? What is the difference in concave and convex mirrors? Most of the students gets confused what are concave and what are convex mirrors. You just remember simply in easy way what are concave, what are convex. Here, what I said, based upon the reflecting surfaces, mirrors have been classified as. Based upon on what basis mirrors have been classified into plane mirrors, convex mirrors, concave mirrors, based upon the reflecting surfaces. So, how does these reflecting surfaces are seen in concave and convex? How does they appear? How can we come to know what are the reflecting surface? How does it look? How does it look? Just you remember, this is a heart. Okay, this is a heart. Or this is your hand. This is a heart. Just remember the reflecting surface for convex. The reflecting surface for convex is always outward. The reflecting surface of convex mirrors is always outward. This is a heart. Okay, outward means convex. Inwards means the reflecting surface means the light ray is coming and striking here, striking toward inwards of your heart. Here the light ray is coming and striking towards inwards. Inside of your heart is nothing but concave. Cave means inner. Cave, you know the cave. Okay, line always lies inside the cave. You just remember, inside. Line always lies inside the cave. Inside, concave. This is the heart. Inside, towards, in reflecting surface is always inwards. Here if you see, this is the mirror, you think. The outside surface. Here, the outside surface I have been polished. Here, outside of the mirror, I have been polished. Here, what happens? That this is a light ray which come to inwards, which coming inwards and striking inwards. For a concave mirror, always the reflecting surface is inwards. Simply, you remember lion in a cave. Lion in a cave. Simply, you remember lion in a cave, inside the cave, inwards. Concave mirrors, inwards. Reflecting surface is inwards. Convex mirrors, this is the heart, the outward reflecting surface. It is the bulged mirror and always the reflecting surface is towards outwards. Always for the convex mirrors, the reflecting surfaces are outwards. For the concave mirrors, reflecting surfaces are towards, inside, inwards. Simply remember, lion inside a cave. Lion always lies inside a cave. Cave, concave. Okay, just remember cave, concave, inwards. Children, understood the phenomenon here? What are concave and convex mirrors? What are the reflecting surface? How they appear? Okay. Now, further deep into the subject, how the formation of images you can see in these mirrors. how you can see the image in the plane mirror, how you can see the images in a spherical mirrors. You should get these one. You should get, these are the important topics for your IPE. You should learn. Okay, if you understand the concept, it is very easy. It is very easy to draw the diagram. Just you remember the diagram, just you remember the figures, so that you can understand the complete concept very well. Understood? Okay, coming to the formation of images right now. How do the images, formation of images? Today's class, just we will learn how the images you can see in a plane mirror. How the images are formed in a plane mirrors. So here you can see the PPT here. How the images are formed in the plane mirrors, children. Just by the way, we know what is incident ray and what is reflected ray. By now, you have known what is the incident ray and what is the reflected ray. What is incident ray, children? The ray which comes and strikes the object is called, for suppose this is the object what we have taken, it is a plane mirror. This is a plane mirror. This is the incident ray which coming, this is the incident ray coming, this is the incident ray, this forms, this is coming and striking an object, this is the incident ray, and this ray have to be reflected. What we have learned, the laws, based upon the laws of reflection, always we have to draw a perpendicular line. This is the perpendicular line, this is considered to be as normal. Here the line which we have drawn straight, which is perpendicular to the object, or here the plane mirror, you can see this is the perpendicular line I have drawn. This is called as normal. And this is the incident ray which come and strike the object and reflected back. And reflected back. Here, what's happening in a plane mirrors? How the images are formed in mirrors? You have to know. The images are always formed in mirrors where the incident ray and the reflected ray both join at one point. Okay, all these rays are coming and reflecting back. Right? We have, I am so much confused. Where, how the images are observed here. Simply remember the point where the incident ray and the reflected ray come and meet at one point. All these rays have to meet at one point. Right? All these rays meet at particular point, somewhere behind the mirror or in front of the mirror. Let us discuss further deep in the next class. That one. Okay. Here what happens in a plane mirror, how the image is formed. Okay, image is always formed. Image is always formed. Remember, children, image is always formed where? Important need bit. Where does the image form? Image is always formed where all the rays come and meet at a point, at a particular point. That particular point, the image you can form. You can see here in this figure. If you observe the PPT, just see where I am crossing. This is the incident ray. This is the incident ray. Okay, this is the incident ray. Just I am drawing an imaginary line here. I am extending the line of incident ray here. This is the reflected ray. I am extending the reflected ray here. Back side of the mirror. Okay, this is the point where, okay, both the incident and reflected ray met. This is the point where both the incident and the reflected ray met. Okay, this is the point where the image is formed. This is the point where the image is formed here. Just you observe the PPT, children, where I am keeping the arrow mark. This is the point where the incident ray and the reflected ray has been met. Okay, I have just drawn the